Here we go. This looks good. Logge natürlich auf der opens on the wrong side. Let's see if this is correct. Yeah, here we go. Right. So let's see. Hello, welcome. I think we are on time this time. Yes, not quite. So we have a minute left, and but with me is already Jens and Jan. Hi.
Hi.
Hello.
Hey. And Jens was kind enough to say yes when I approached him, not to say bother him on Twitter, to tell us a bit more about his little project, little big project. And before I say anything more, I will just give a couple of informations. We already have like around 11 people in the stream or on the stream, and I just had a quick chat with Jan. I think Jan, you said that it would be a great idea to have like some questions between the 4 bigger sessions. So Jan and I will collect all the questions from the live chat and we'll then relay them to you once it's on the time. And if you ask questions and no one wants to answer, Jan or I have to jump on. Right, with all this, I think we should and can start. So we have 16 already and everyone else joining will be fine. So I will shut up now and the stage is yours, Jan. Have fun.
Thank you very much. Welcome for this talk about Fritz 2. This is a little framework Jan and I built to easily build reactive web apps in pure Kotlin. And I'm happy to be able to tell you a little about 60 minutes, I think, about the features and why we decided to do it and what it's all about. So this is a premiere for me in several ways. It's my first virtual talk at all. Let's see how this will work out. And it's my second talk in English, I think. And in a few minutes, you will know why. So please be kind. I will do my very best. And I hope I will get some support if I'm unable to express what I want to say. So, okay, let's start. A few words about us. We are 2 who started the project. It's Jan Weidenhaupt. He successfully completed his studies of computer science this year and is application developer at Öffentliche Versicherung, the insurance company we work at. And he is right now active in Spring, Scala, Go, Kotlin, of course, and Docker. And myself, I started developing in 1986, a little older than Jan, on a C64. And right now I'm working as the head of IT architecture and data analytics at the insurance company. And I worked a lot in Scala, started with Kotlin a few months ago, and a lot of Spring and Kubernetes and things like that. So let's right jump in. And if you remember, the title of the talk is Easily Building Reactive Web Apps in Pure Kotlin. And so the first question to answer is, why Kotlin for web apps? And there are a few aspects. Sorry, this is a German article, but there's nothing more in it that Google makes Kotlin the first choice for Android app development. And also, Kotlin support is introduced in Spring Framework with version 5, and so Kotlin is gaining popularity very fast. And we have some Android development, but a lot of more Spring development in our company. So it's a great asset to be able to do front-end development in the same language and the same ecosystem like the backend development. Also, we are a rather small company with about 100 IT persons in IT and maybe 20, 25 web developers. So most of us are doing full stack, and this makes it even more important that you don't have to switch between the 2 ecosystems, JavaScript and your backend, whatever it is, again and again. Also, this is the Kotlin user group, so I think I don't have to tell you much about the pros of Kotlin. It's a very concise language. It's safe. It's interoperable. It's stable. So free to have a look at the Kotlin web page to get a lot more of the good sides of Kotlin. And of course, Kotlin is gaining popularity among companies, but also among developers very fast. If you have a look at Stack Overflow, the amount of questions is growing incredibly fast, and it's on GitHub, it's the fastest growing programming language overall. So these are all criteria for us that we wanted to have a look at Kotlin and try to evaluate the chances to use this for our front-end development. I already said that the ecosystem was important for us, and with Kotlin and Kotlin.js in particular, you are able to use your build scripts, your dependency management, your unit tests, everything else in Gradle. So a platform we are already productive with, and we know quite a little about, and we feel familiar with. And you don't have to switch this to a completely different world like NPM or Yarn or whatever you want to use on the JavaScript side. Same is true for unit tests, of course, and this makes the introduction, especially for a company, much easier. Also, you have a great tooling. No surprise if it's done by JetBrains. You get everything you know from your Java development or Scala development, even more than you know from your Scala development. To be honest, you get a great code completion. You get all the refactorings you might need when you want to develop a larger project. And what was a surprise for me, at least, when it comes to debugging, you can debug your compiled JavaScript code, of course, with code maps, source maps. This is possible, for example, in binding Scala too, but especially in Scala, we used this for the past 3 years a lot. It is quite difficult to find your own values and variables you want to debug in between the huge amount of attributes and elements the compiler creates when translating your Scala code to JavaScript. And in Kotlin, this is much cleaner. As you can see, we have here a breakpoint, and we have, for example, a variable called model and a value called Hugo, and if you, I want to zoom in, but it doesn't work. So maybe you can see it on your screen. You will find exactly this text in your local variables, and watch point and everything else work like a charm. And this is in the browser. You of course can add a little plugin to your browser, and then you can debug in your IntelliJ IDE like you're used to. Okay, so this is about Kotlin and why we wanted to use, or we try to use Kotlin for front-end development for us. And now I will try to show you how this feels live. I don't know how many of you have ever tried Kotlin.js over the last few months, and I, for myself, was a little surprised how good this works out. And so I want to take the chance and show it to you. I have to share my screen, reshare my screen. Okay. I hope you can see my browser. And so this is our Fritz documentation page, and we have a little project set up. From there on, you can go to GitHub and get a little template. And this template is nothing more than a small build file in Gradle and a very small index HTML and an even smaller Kotlin script. So nothing more in it, and you just can click on this button to use this template and give it a name. Create a repository from this, and okay. Now we take this, and I think I have to stop it again. Okay. So we can go on, make a new project from version control. Hopefully see it on GitHub. There it is. Clone it. Open it. So here it is. While it does its indexing, we can have a look at it. Just as I said, a small build script, really not much in it, just the dependencies for Kotlin and the one and single dependency for Fritz 2 core. And we have to tell it that it should run in the browser. And in addition to that, a small index file, just a body with an ID. And the app is even smaller. It just renders a little HTML, and that's all. And now you get your Gradle project to have some tasks. Different run configurations. We use the default one, and when calling it the first time, it takes a few seconds. But if you ever work, for example, with binding Scala or another transpiler, it's for me, it's very fast. Just have to wait a few seconds and then the browser will open, hopefully. Okay, there it is. You've seen the loading from the index HTML and now the rendered project I've shown you. I will close this. Let me just demonstrate you one more thing. If you go on and edit this a little, add a little argument and run it again. Now it's much faster. So here we are again. And now let's change something and save it. And as you can see, the compiler started again. And there's the result. So at least for me, it feels quite a little like native JavaScript development when it comes to speed. Okay, so that's all of this. And now back again to the presentation. Okay. So this was the first part. You remember easily building reactive web apps in pure Kotlin, and this was the Kotlin part. And now we come to the next part. It's about web apps. We want to build web apps, so we have to find a way to get a way to define our HTML. And so Fritz 2 offers you a small DSL that allows you to write typesafe HTML. You call a factory method called render, mount your result to something in your HTML, in your base index HTML, in our example, over the ID. And from there, you can build the HTML elements, like you know from other DSLs. Kotlinx HTML looks quite the same in many ways. And you can nest your elements, of course, like the several divs we have here. You can add text nodes at any point where a text node can appear, and this is fully type checked. So you also have all the attributes of the elements available, and you have, of course, code completion for it, and you can just bind it to the right types. In addition to elements and attributes, you also get your events, your HTML events. For example, the clicks of a button at this point. How this works, we will see later on. But just for now, they are also typed, and you see the events that really exist. Now it gets a little different from kotlinx HTML. We decided to allow defining static base CSS classes right in the parameter section of your elements. Like here, you can add main after your section, and this will just add the CSS class main to your section element. Important is that this is static. You cannot change it later, but it's quite useful for us since we prefer semantic CSS. So you can add some more meaning to your elements. This is the main section, or this is, if you continue in the example, this is not just an unsorted list, it's your to-do list. And the list item is not any item, it's a to-do item and everything like this. And also it gets a little out of the way of your dynamic parts of your application, and it's there where it belongs, right next to the elements. Also important is that you have always full access to the browser DOM API at any point in this DSL. You can at any point access a property called DOM node, for example, of this input. And you can call all the methods that an input would offer you normally in the DOM API. So you can focus, you can select parts of your text, whatever you want to do with your DOM node. And last but not least, we have no boilerplate models. So when you have some data that you want to build your web app on, you just define a data class like a person for this example, and add the attributes. And the only thing that we are in quite some intrusive right now is that at some point you have to implement an interface like with ID, but this may change in the future too. Okay, so this is about building web apps, and since we now have data in our web app, the next thing we have to do is state management. This is, I think, what single-page applications are really all about. So you need you need some thing to manage your state and the changes of your state. And I think most of you might have played around or worked with React.js. And React.js components have a life cycle. So you have quite many methods defining the life cycle of your component that are called when it's initialized, when it's mounted, or you have to implement it to decide if a component should be re-rendered when an update occurs. And of course, you can get notified when it's unmounted. The circle of life in Fritz 2 is quite different. It's reactive, as we said. So we have a store at our left side of this picture. And this store holds your data, whatever your model is, from a single simple string to a most complex model with many nested classes and lists and so on. And this store offers a flow of values. That means that whenever the data in your store changes on this flow, there will be another value, the actual value of data in your store. Now you go on and map these values on the flow to a tree of text. This is what you do with this render factory methods. You take your data and create HTML text from it. And at last, you bind this to a mount point. So you define where in your totally DOM tree these texts should appear later on. And this mount point is responsible for updating, for doing the real DOM updates later on. So it's always the same chain. Whenever your data in the store changes, a new value will appear on the flow, will be mapped over many different intermediate actions to a subtree of HTML tags, and the mount point will update this part of the DOM tree. And on the other part from the DOM, there occur events, and these events are also offered to you in the DSL as a flow. So whenever an event of a certain type at a certain element occurs on this flow, a new event will occur. And again, you go on and map it to some actions. So maybe you have clicks on a button and you decide to make an action from it that you want to delete a certain item in your store. And this actions flow is then bound to a handler. This handler does the same as the mount point on the other side. It's responsible to update for updating your store. It knows how to handle this action and how to handle its parameters and updates the data in your store accordingly. So the circle is closed. And this is everything you have to do since it's fully reactive. You don't have any more lifecycle methods. It's always the same and just run this one circle. Now I used the word flow a lot on the last slide. Flows are part of kotlinx.coroutines, and there's a lot more to learn about flows than I can tell you right now. For us, it's enough to know that a flow is a time-discrete stream of values. So as I said, whenever the source of your flow creates a new value, this appears on the flow, and then the next, and the next, and the next, and ever so on. And the next thing we have to remember is it is code. There's also much to read about this, but for now, this means that the producer of the values for us in the store does not need to hold references to the processors of this value. So this makes it quite easy, and you don't have to do lifecycle management of your components by yourself, since they will disappear automatically. And you can do a lot of things with the flow. I already said you can map the values of the flow. You can enrich it, usually by calling flatmap. You can filter your values. You can share your flow between many different processors. You can combine flows. For example, if you want to combine two events to do the same for a key press and a key up and a key down or whatever, you can conflate flows. This is also quite important because on these flows, the processors have their own speed of working. So whenever a new value, whenever a processor is ready to process the next value, it asks over the chain at the producer if there's something ready and take this new value. And when this takes a while, maybe there have been 2 or 3 or more new values available on the flow, but the processor will only take the last actual one. So for the mount point, this means that you will always only render what can be rendered because of the speed of your browser and your computer, and not the intermediate states. And of course, you can buffer values and many more things. So what this allows us to do is at first a separation of concerns. You have somewhere in your code the definition of your store. It's just an object inheriting from a root store, and it has a type. For a first example, just a string. You give it an initial value and, if you like, an idea, and that's all. Now you have a store, and you use this somewhere else in your render method. Build up your tree, and in this example you just use the store's data to bind it to the value attribute of the input element. This means whenever the data in your store changes, the value attribute and just the value attribute of this input component will change in the DOM, and so you will see the result in the browser. And the same is, of course, can be done with attributes and also with elements. So here you bind this data flow of your store at this point. here a mount point is created, and this means that exactly this text node that is created here will be updated whenever your store data changes. So just to have a quick look, this is the example I just showed you, a little more, but just a little more styling. And this is the input. And whenever you type something here, you see it in the value, and that's all. So this is the one side of the circle of life, and the other side is about the events and handlers. So it's basically the same as you've already seen. You have the events, the HTML events available in our DSL. For example, at this input, you have the changes events. And in this example, you map these changes to actions by just calling a convenience method called values. This does nothing more than extracting the actual value from your input and gives it as the action value. And now using a function called handled by, you connect this to a handler. In this case, to the store update handler. Every store has a handler called update, and this takes as an action just a value of the type of the store and replaces the old value by this new value called updates. And in our example, this is what you've seen when you input something. When you write something in the input field, this event is fired and is handled by this update handler, and the data of your store is changed. So on the data flow, there's a new value available, and you map this to the current value text node, and so it is rendered again. And in addition, you have, for example, the clicks events that are handled by another defined handler store at a dot. And if you want to create a handler, you would just call a little factory method. This is a handler in this example that takes no action, just the actual model value, and maps the actual model value by just adding another dot, like the name said. And this is called whenever you click on the button. Okay, as you've seen, this is fully declarative. So you can call all the intermediate actions on your flows, as well on the event flows as on the data flows. And for example, you can take the activities of a person and filter it for the activities the person likes, and map it to just a plain string consisting of the name of the activity, and then join all the activities to a simple string. You know this from Java streams, for example, or everything else. And you can do this with our data that we get from our store. For example, we can count when we have a to-do list, we can count all the to-dos that are not yet completed and put this into a new flow called count. Another important feature at this place is that you can call a single method called distinct until changed, and it does exactly that. Your new flow count will only offer a new value when the count of your to-dos has really changed. So you will never re-render something when there's no need for it. And now you can take this count flow again and map it to a string, like telling how much items are left. And this you can bind, as you have seen, back to your DOM. We've already seen how to add static classes to your elements, and of course you will have the need to add dynamic classes that are changed when your model changes. And this can be done in 3 ways. You can use a property called class name, and you just assign it to a flow of strings, or assign a flow of strings to it. And then this class name will be added to your element. And this can, of course, reactively change like with every other element. You can also use class list, and then offered more than one class, and those will just be concatenated. It's just a little more convenient to operate on. And you can use a map from string to Boolean. So your string keys consist of the name of your classes, and wherever your value is true, this will be concatenated and added to your element. In this example, the completed will be added when your to-do is completed, and it will be removed when it is not anymore, automatically when your data in your store changes. Of course, you can have quite more complex data models. Like in this example, you have a person, and the person has, for example, an address. And the address, again, has some properties like street, number, postal code, and so on. And now you have a person store, like you've already seen with the string, the same, exactly the same. And you can, by just calling a method called sub, you can create a substore for every property you want from this person. For example, for the name, just call person store.sub. And now you have to give Fritz2 the path from your outer entity to the inner entity that you want the substore to handle. And you do this by just adding lenses over your data class, and then a Gradle plugin creates the code you need. So you get an object called lenses in your package, and there you will find all your data classes that are annotated, and you can just enter your path, in this case from person to name. Now you have a store that handles your name, and it works exactly like any other root store that we've already seen. You can bind it, for example, to the paragraph, and in this case, the name of the person will just render in this paragraph. And of course, you can update it as well. And if you update the value of a substore, like you might have guessed, the partial value of the parent store will, of course, also be updated automatically. And you can go on with this. So you can create an address store from your person by just use the right lens from person to address. And then you can create another substore from this address store by calling the lens from address to street and have a street store. And again, this sub store works again as any other store. So you can bind, for example, the data from the store to your value attribute, and you can use the change events like we've seen and let it be handled by the update handler of the street store. And what you've done right now is just two-way data binding for this input. That's all. The same you can do with sequences. Again, the example of the person, and the person has a list of activities. Activities has also some properties on its own. And again, you create just a person store, a root store, and now you create a substore for the activities. And this store has, of course, a list of activities as its data type. And that on its data flow, you can call a method called each, and this creates a sequence for you. You can then map each element of this sequence. It's of course an activity, and can render, for example, a list element for each activity in this unsorted list. But now each is a little different. It's not just iterating over the list and adding the elements, but it takes and it tries to determine whenever a new list appears on the flow, what patches have to be made to your DOM to reflect the changes in your data. So if you added a new activity at the end of the list, you will get a patch that will do exactly that to your DOM. It will add another list item at the end of your unsorted list. And the same is true if you do it in the middle of the list, then just a single list item will be added. And even if you move the second item of your activities to the fourth place, it will take exactly the DOM node from the second place and move it to the fourth place. So you will always get the minimum DOM activities that are needed. And this is to do this, you have to implement the interface with ID, so we can Fritz2 will be able to determine that two elements in your list are still the same. Also, the internal data has changed. Okay, now you can also use the sub method to get a substore of a certain element of your list. On the example before, you've just rendered out the elements, and if you want to do two-way data binding, for example, or something like this, you need a store again, and you can get this store by just calling the sub method again with this lens and give it the right parameter. We have also a convenience method here. You can call on the store each store, and this makes it a little easier. So you can, so you get as a new parameter for your mapping method, mapping function. You get already the store and can go on and use it to do your two-way data binding. Okay, and this is what I just said before. If you cannot call the each store convenience method, maybe because you want to filter your data before you map it, you can call the sub function, give it the activity you want, and get the actual store for exactly this list item. And this is again just a normal store you can bind to everything you want. The store and the hierarchy of stores offers you also the mechanism to generate meaningful IDs by just adding, concatenating the names of the properties on your path. So if you call at this activity store the ID, you get .activities, and later on in your list item, when you call the ID, you get activities from here, and it's a sub item of a certain element of your list. So you get the list, the ID of this list item, a UUID in our case, and then because it's a name store, you get a name. And so you always get a meaningful ID for automatic tests, or maybe for accessing the elements when you want to render error messages or something like that. Okay, so I've talked already a lot. Just one more thing for state management. It's of course the examples are quite small, but it's of course also possible to use inheritance to define an interface for maybe a CRUD store and define what handlers a CRUD store would offer, and then implement a local storage CRUD store, for example, and handle these methods. So you can use the local store in your browser, and then later use this in your project. So you can use every mechanism you like to structure your code and keep the don't repeat yourself principle intact. So this would be a good place to ask for some questions.
And we do actually have some. I hope I'm not butchering the name completely, but it's from Gilles van Gulp. Sorry if I said anything offensive. He has two questions. One is packed with a few sub questions, which is, would love comments on the practicalities of building, testing, deploying, and runtime overhead, and what the actual handling of debugging and breakpoints is. So yeah. So let's start with the first bit. So how does it look like? What's the actual deployable, and how do you deploy the whole? So what's the end result? I do expect you do get like HTML, CSS, and JS files.
Yes.
Can you maybe show it somehow?
Of course.
If not, it's fine, but I think you have it in
No,
your
it's okay.
IDE anyway, so.
It's okay. So we will use our example from before. This is our Kotlin code, and this is our HTML. And you get a single JavaScript file from this. You just add to your index HTML, and everything from your resource folder will be copied together with this JavaScript file to your distribution. So just let me find it. Okay. If you call browser distribution, this could take a little while, and this will take all your JavaScript and the Kotlin standard lib and all other libs that you might use in your project. Fritz 2 has no other dependencies, but you can, of course, use whatever you like.
Did you say it has no other dependencies, or does have external dependencies?
No other.
No other.
It's
okay.
Just pure Kotlin so far.
That's fine.
And it does a lot of dead code elimination. So your JavaScript is quite small for JavaScript of a transpiled language. So for our example, it's about 100K. Not very small if you do native JavaScript, of course, but if you have a look at binding Scala or other things, you often get megabytes of data. And the dead code elimination of Kotlin JS is already that good. I tried to run the Clojure compiler, Google Clojure compiler on it, and it removes just 2 more bytes.
Okay,
nothing.
fair enough.
So it's nearly perfect. And as far as I know, JetBrains is working on some other mechanisms to make this even smaller, and to maybe to split it up in several JS files you can load when you need them. But that's not ready.
That would be great. Yeah. I think Jakob mentioned this, that with a little bit of luck in the next, say, minor release, so 0.4, it's behind the, I think it was a 1.4. Yeah, 1.4. We hopefully get the new compiler, so it should even get a bit more efficient even then, or even more efficient then. And Giles, sorry for that, also ask, what do you use to create this presentation?
Oh, this is slides.com. It's Reveal.js, and if you don't want to write your JavaScript code by yourself, you can use slides.com and then click it together.
Perfect, thank you. So let's see if there are any other questions. I think Jan is also answering very, very nicely on here, so thanks for this. Yeah, there is another one. There was the question, I think you answered this at the beginning, just to make sure. So you can use Chrome developer tools and other things to debug the actual JavaScript which comes out of this process, right?
Yes.
Yeah, okay, cool.
Just use your normal developer development tools, and source maps are generated. And behind this works just web and yarn and npm and everything you know from your from your JavaScript builds. But this is also everything is handled by the Gradle plugins, so you don't have to do this yourself. But you can do, of course, you can add everything you know from your Webpack configuration right here, and set up local development proxies, add other files, whatever you want to, and also you can of course use thus and less and whatever you like in your build process.
And I had one question, so I'm not quite sure. I think you answered it already partly. So I can mix HTML, classic HTML, JavaScript, CSS with the nice Kotlin HTML, DSL, and all the nice things I get from Fritz, right? So you said like everything in resources gets into it as well.
Yes.
Yeah. Okay.
Everything in resources is copied over here, and you can use it, of course, and you can access the DOM API from everywhere in the DSL.
Perfect. So I think that should be it for, I think these were all the questions we had so far. Giles says thanks, by the way. So he seems to be happy with the answer, and
Okay.
it's your stage again.
Okay. So still on state management, we'll just go quite fast over it and answer questions after it, or we offer or we support asynchronous operations, of course, when you want to do some long-running operations in your handlers, and of course you don't want to block. You can do this by combining a handler, like you already know, with something we call apply, and combine this by just calling and then, and build chains from long-running operations and your handlers that you can then, the result of this is load, and this is a handler by itself, so you can use it in your code like you've already seen, and just bind it to any event stream. And of course, you can have more than one store. So maybe you want to have a person store, like we've already seen, that has a save handler, and like the handle method, it's there's also a method available called handle and emit, and you can emit new values by just calling the offer method, and this handler is also a stream by itself. So you can set another store, a list store, for example, that has an add handler, and you can just bind this together like you have seen with the event streams. You can say that whenever a person store save offers something, then this is handled by list store add. And so whenever this offer is called from save, the add handler at the list store is called. And so you can build chains of whatever you want to do to connect your stores together, and don't have to put everything in one store. So maybe this example isn't perfect because you of course have the possibility of sub-stores, and you have always to decide if this is the right, or you want to use two different stores for this. Okay, so that's all about state management. Just a quick look at routing. Routing is, of course, so I've a little sun over here. Just be back. Okay, sorry. Now I can see my screen again. We offer hash-based routing, and it's quite simple. You just define a router. There are several ways for a router, just handling strings, or you can also get a map of your attributes, of your named attributes, which we do in this case. And then you can use this with a select on the parameter. And over a simple when, you can define if you route this page's home, then you render whatever's on the home page, and if your route is page's show, you render whatever is on your render page. And navigating is as easy. You can just create a navbar, for example, and in this example you have your clicks on your anchors, and here you define the parameter list you want to use for the navigation. You set the page parameter to home and just give it to the nav2 handler of the router, and so this will navigate you to hash page is equals to home. So just see it, and the same is for the show, for example. So here you have three different navigation links, and this is exactly the example I showed you. You can click on the links, and then the handler is called to do the navigation. And so here are some extra parameters, for example, when you call this, and this is just rendered at the right place. And of course, you can do this from any event that you like. So this we think this should support many of the routing situations that can occur in single page applications. Of course, you are free to do everything on your own, to deserialize your parameters to an object, or just use the basic string, or use a slash-based routing, whatever you want. You can implement everything, but this is what we already offer as a complete solution. Built-in solution, not complete. Okay. So this is about routing and deep links for your application. We also support validation. To do this, you have to define your validation messages. This is just a small interface you have to implement, and you can decide on your own what attributes your message should have. Maybe an ID to identify where the error is. Maybe a CSS class to set if an error occurred, and of course a text you want to render. And you have to implement a method called fail that determines if this message leads to a failure in the validation, or it's just a warning message. And then you go on and write a validator by just implementing the validator interface. You have to say what you want to define, to validate, what messages you want to return, and you can use some metadata for your information, maybe a validation step. Do you want to validate before save or after save, or wherever you are in your business process? And all you have to do is to implement the one validate method. In this case, you build a list of messages. You get your root ID from your store, so that the ideas from your validator match to the ideas generated by your store. And then you write your validation rules and add a message whenever you want. So this is an error message, status invalid for this case, and gives this text. And the next one is a positive message, so it's valid and gives a positive text. And now you add this to your store, so you create a root store for a person, like we've already seen, and just add validation in the inheritance. Tell the store which validator it should use, the person validator we just wrote, and then you can use the validate method you just have defined in your handler wherever you like, and react to the result. So you've implemented if this is a failure or not, and so this will return true or false depending on your messages. And last but not least, you have to show your messages. So in this example, whenever your store calls this validation, the validator has its own flow called messages, and on each message we will walk through our DOM and get the element of the according idea and add the message class that we defined in the data class. So if we define this, we get a form that behaves like you might guess. Whenever the validate method is called, your fields get read and the text is rendered below the fields. Okay, that's validation. We also have a small remote API to make it easier to call remote APIs of your backend. It's just a small wrapper about the fetch API, around the fetch API of the browser. You create a remote with a base URL. You can configure it to accept JSON or whatever you like, set headers, set authentication, and so on. And then you use the apply we have seen before to call the get method on this user's remote and handle errors and use the body as a result, for example. And in this example, the body will be used to update the store's value. And of course, you can do the same with post. And then you have to set the body before you call the method. Of course, you don't want to code the JSON by your own. You can use the basic built-in JavaScript methods, or you can of course use kotlinx serialization and let this do the work for you. Okay, so we are just nearly done. Some assets, already said it. We try to keep it as small and simple as it's possible. Fritz2 consists of only about 1,500 lines of code in the core. And it's really 100% pure Kotlin. It has no dependencies, and that's possible because all the magic is done by kotlinx.coroutines, of course. Fritz2 is just a small lib to define a convenient API for a very special use case, but all the hard work is done by kotlinx.coroutines in this case. We have some documentation, so we would be very happy if you decide to play a little around with Fritz2. Have a look at it and be assured that there will be quite some errors and quite some language errors, and maybe also some content errors. So we would be happy if you let us know if you find something in the documentation that is not complete or wrong or whatever. And of course, the normal API documentation is also available. And we have a little set of examples, about 7, I think, right now. You can have a look at, and so this is a good chance to have a look at a more complete code. Especially, we have a to-do MVC example to compare Fritz2 to other frameworks like React or Angular or whatever. And you can see that we have the solution, one of the solutions with the least lines of code. So not that this is a quality, but yeah, have a look on by yourself. And this is quite a good example. I think you can see many of the things I've tried to tell you, to show you there in action and in a complete working together example. So this might be a good point to see Fritz2 in action and start from there with your own projects. Okay, thank you very much. And are there any more questions?
Oh, yes, there are. There are. Giles is very, very happy with what he sees. The money quote is, in my humble opinion, we have a React, Vue, or Angular killer solution here. And he also asked a broader question. I think, well, he did ask 2, but they kind of belong together. So he asked, what potential do you see for bringing in stuff from the Android world? There's a lot of good frameworks and idioms there. And he kind of clarified on this by saying he was also going towards like cross-platform, so to use this for development for iOS and Google's Flutter, something like that. So are there any plans, I think, is the questions behind this, to go towards kind of this cross-platform mobile development?
So you can of course use this since it's JavaScript, HTML, and CSS. In the result, you can use this, of course, to build mobile applications and pack this together with a browser or something like this. There are already quite a lot of libraries doing something like this on Android in Kotlin. So this is not new.
All right, cool. Then Gleb Rodionov, and I'm pretty sure I butchered this as well, sorry. He asks a question about packaging. Is there any way to generate a jar for front, for back, and or for both? So he's asking towards like fat jar, so have one big thing to run.
Yes. So you can create NPM packages, Node.js packages from whatever your result is. For example, Fritz2 allows you to build web components, and you can package this as an NPM. And of course, this is what we've done at our company. You can create web jars from there, just by the normal Gradle plugins that are available, and use these web jars, for example, declare a dependency in your Spring Boot project, and when building the fat jar of the Spring Boot project, your web jar will be included, and then you have one really fat jar with all your backend and front end together.
Make it big, yeah. Alessandro Pinto asks, how hard is it to insert frameworks like Design Material or Bootstrap? Is it just add scripts and links in the project? I think you answered this part.
I think so, yes. We think about implementing one of those, or start implementing one of those, maybe Bootstrap. And then you just can add the npm dependency, for example, in your Gradle script, and it will get you the CSS, for example, and then you can use this. And maybe you want to recode the logic of the Bootstrap components in Kotlin, then you will have to do this, or we might start to do this. Or you can, of course, also use the JavaScript and use this to manipulate over the DOM node access.
Sweet. Jakob asks, is there a concept of components?
Yes, several. So maybe I share my desktop again. So we have a little text about this. And so you can have a component, of course, by just defining a value. And this is for non-dynamic components. If you want to render a certain element again, then this is just a function on this data class, and you can render from there and call this from your parent component. And of course, you can define an extension function on this HTML elements to give it a parameter and call this from your parent component. So this is a simple function is your component mechanism, if you like. Of course, you can encapsulate this in an object and put together things that belong together, or can encapsulate more of these in a class. But basically, it's just an extension function, or even if you don't need any parameters, even an extension property.
Cool, perfect. You just said, I'm not sure if there are any other questions coming, so just give them a couple of minutes. You said that you could use some help with the project. So what's the best way to start? Is it just to contact you, or is it go to GitHub, clone it, and raise the pull request? So what's the preferred way?
Yes, you can of course go to GitHub, just clone the project. There are quite some open issues, and they are marked where we need help. We really would appreciate help with our Gradle build scripts to clean this up and to optimize it. It works, but we are pretty sure that there's much more possible with this. And of course, there are quite some other issues. So yes, have a look at it, and we would be happy to talk to you what can be done. Maybe you have a completely different idea what can be included. As I said, we want to try to keep Fritz itself as small as possible. So I don't think we will add many more features in the core project. But of course, we could imagine a Fritz to Bootstrap to implement the Bootstrap components, or something completely different in another sub-project.
All right. So Gleb just said that he had a look at the documentation, and he says that there is not a lot of explanation about the packaging process, just a pointer to Gradle run. So he would love to have this a bit more clarified. Gleb, if you hear it, feel free to start the edit process. Alessandro jumps in with another question. He says, I have a last question. Do you have a roadmap for future features? What's the plans for the future?
So we have quite some issues that we have to implement. We have still some renaming to do on our packages because of the domain names. We have to adjust to the new Kotlin versions. And I think this will be done over the next few weeks. And at our insurance company, we will start a project in the mid of June to build a component library based on Fritz 2 for our own business application. This will not be open source, but we will keep on using Fritz at this project and hope to get it stable over the run of this year, and maybe have a 1.0 production ready version in December.
Oh boy, you just said it on tape. Right, so I think if there are not any more questions, yeah, thank you so much. It was really, really great. I definitely have to watch it again just to essentially play along, and hopefully see you soon again. And thanks for being here.
Yes, thank you for the possibility to talk about it.
You're more than welcome. All right, guys and folks, that's it for today. Right, so hopefully see you next time. If you have a talk you want to give here, please approach us via YouTube or via Slack channel, and see you hopefully soon. Have a good one. Bye-bye.
Bye-bye.